Hi, scholars. In this video, we're going to define the term isotope and describe some ways in which isotopes are useful in studying biology. So, what is an isotope? There are images of three different isotopes of oxygen here, oxygen 16, oxygen 17, and oxygen 18. And they're all atoms of oxygen, but they have different mass numbers. And so that's how we differentiate them: oxygen 16, oxygen 17, oxygen 18. Take a few seconds to think about what's similar and different about these three isotopes of oxygen shown to the right. Based on this, so you can see they have the same electrons, so they're going to react the same in chemical reactions. They have the same number of protons, that's what makes them all oxygen, but they have different numbers of neutrons. And while that doesn't affect how the atom acts in chemical reactions and doesn't change the fact that they're all atoms of oxygen, that ratio of neutrons to protons can make some isotopes radioactive, can make the nucleus of some isotopes radioactive, while other isotopes of the same element are not. So take some time to record a good definition of the term isotope in your notebooks. A lot of times we use especially less common isotopes in research as tracers. Mainly because since they have the same amount of electrons as the most common isotope in nature, they're going to react the same way during chemical reactions. They have the same number of valence electrons as the most common isotope, but they can be detected from the most common isotope in one of two ways, in some cases in both ways. So first of all, because of that different ratio of neutrons to protons, some isotopes are radioactive while the most common isotope of the element is not. And so we can use that radioactive version as a tracer because we can locate radiation as it's given off. Secondly, they literally have a difference in mass. So in some cases, we can determine where this less common isotope is going because we can find it by weighing it out and finding the difference in mass. So I'm gonna have you watch a couple of videos here. You'll start with this video on the left, which is showing how we can use a radioactive isotope of carbon to kind of measure and test for photosynthesis. And so as you watch the video, be prepared to leave a brief summary of why you think the video is important, like how they used isotopes, how they're using isotopes to research biology. In the second video here, you'll be learning about radiocarbon dating. So again, as you watch the video, you might want to take some notes. Be ready to leave a brief summary of how isotopes are used in radiocarbon dating. So hopefully at the end of this video, you know what an isotope is, and you can give an example of how we can use isotopes to learn more about biology.